Hello to the Graken community. Very pleased to be here. I hope everyone's still hanging in because I'm the last session. So thanks for hanging in. Type Refinery, it's the kind of next step in TypeDB visualization. And it came about when I was working with Graken, as it was called then, about 14 months ago. And I noticed something. And I was working on process mining. For those that know my interests, I'm very interested in time, and process mining is a key way of dealing with time. And process logs are very simple, a pattern and a common kind of Graken data design pattern, and it's similar to a Russian doll, and that we have components that are nested inside each other. So a log contains one or more sessions, a session contains one or more events, and an event contain one or more pieces of data. So graphically, what we're looking at is a nested scenario where I got a session and I got events. And I have a directly follows relationship between them. And then right at the end, I have an end event. And we often in process mining, we put dummy stop events to make it easy to query. And then I have multiple sessions. So essentially I have objects within objects within objects. And this might be a very, very simple data set, and I can model that very, very clearly inside TypeDB. And if you want to look at the actual TypeQL that's used for it, you can see that we've got an event with a single piece of data and an event name. We've got a log that's got its own name, and the trace are really the session, what holds the session, and the trace ID is the session ID. And you can see the directly follows relationship right there. So that's pretty much as simple as we can get data. And if I just wanted to put in letters as the data, so I've got simply a 5-row matrix with the first 3 rows being A, B, C, D, the next 2 rows being A, C, B, D, and then the final row A, E, D. And so my table of input data would look like this, all very straightforward. It leads to a pretty complicated visualization, which is going to look like that. And we can just do a quick example here. Just get the query. And when I was working on this a year or so ago, I would get feedback that looked like this. And my question is, have I loaded the data correctly? By the way, just so everybody can understand the power situation, I'm running the server locally and quite a few things locally. But what we can see is we do get the responses back pretty quickly, but essentially it comes back as a fairly good hairball. I can, through a dint of kind of like hard work, I can start dragging some of these out to make sense and actually lay it out over about, takes about 10 or 15 minutes to lay it out so I can see the data structure behind it. But it certainly is tricky to see what's inside it. And so even very simple data, it's very hard to answer the question of just, have I loaded the right data? And when I was beginning with Graken, that turned out to be the most important thing I was looking for. Have I put the right stuff in there? And it turned out to be very, very difficult. And at the time I thought, shit, there's got to be a better way of doing this. The other thing was I'd kind of been jealous because I'd seen some quite nice layouts. And as an example, here's a couple from literature. This is the Serengeti Food Web. And what's interesting about this is the person's laid the data out, and they've laid it out according to properties in the data. So over down here, we have some kind of vertical row with horizontal groupings, which represent plants. These green things are plants. The blue things are herbivores, and the red things are carnivores. And what you can see is kind of like 3 vertical axes with a number of little horizontal axes working together. So there's been some quite strong layout in that data layout. Another approach to be looking at a biological network. Like if I got a biological network, I need to be able to set this up as layers and try to understand it. There's also kind of like high-end property graph tools. Here's an example from SemSpec, and what we see is a set of subgroups and a question and answer process being driven through. Moving on, let's move on to my favorites, which is layered viewpoints, and here's actually a journal which contains the Pizzagate theory, the results of it, and finally the one that I really like to build, which I decided I wanted to build, which is something like this, where I could show through an isometric layout. And you'll notice here I also have groupings, because I've got horizontal groupings across each layout. So we have 3 layers, and then like groups within them. And I'm like, well, why can't I do this with Kraken? You know, what's the problem? So the more I looked into it, the more I realized that basically I needed a whole new visual grammar. And when you look at why I can lay stuff out pretty good with a property graph, I've got essentially 2 types of structures, and they work out as composite data objects. So they're actually like a rich piece of data, like I've got a person or a city, and you know, all these properties are filled out, and it makes it very easy to lay it out, because I can say, you know, use property 1 as the vertical axis and property 2 as the horizontal axis, and you know, it makes it all very easy. And essentially they become out like mini tables. Instead, if we look at TypeDB, we've got 2 different structures. We've got a thing that can own a sub attribute. So that's a common structure where we have an entity, an attribute, or a relation that owns a sub attribute. We've also got relations that have roles that lead to things. So to things. So in TypeDB, we don't have composite data objects. We've got atomic data objects, and everything's loaded in patterns. So that's going to make it real hard to lay out. So the first thing I'm like, well, okay, so somehow if I want to do layout, I've got to form rich composite objects. And to do that, I'd need to form some kind of semantic disjoint groups. But hey, presto, the attributes in Kraken are unique. And by that, I mean, if we look here, oops, we look here at one of the event names here, we can see that this piece of data, this event name, is linked to a whole load of instantiations or uses where that piece of data is used. And what that means is that visually, the events which use the data are clustered around the data. And so that while the unique attributes are a very useful thing, you can't group with them. So a hypothesis is that we'd need to create some kind of local copy, a shadow copy, if I wanted to do grouping. The other thing, pardon me, unique attributes are visually complicated because they pull the way force graphs work with force and tension, etc., is they cluster things around them. So I'd actually need to disconnect them if I wanted to get some kind of layout that showed the semantics of what was going on. The other problem is if I try to group things, it can kind of look complex. So ideally, I'd need some kind of self-describing capability. So if I grouped things, it could give me a summary of what's inside that group. And finally, then, even if I group them, they're not objects. So I'd need to be able to collapse those groups into objects. And, you know, I see these are the 5 of the causes of TypeDB visual complexity, and I needed all 5 actions in order for visual clarity. But looking into the subpatterns a little bit more, I focused in on 4 different types of disjoint groups I was interested in. And, whoop, shit, sorry about that. And the first one was, let me just get back to that. is where I've got a thing that owns a sub attribute, and its complement is essentially exactly the same scenarios where I've got a relation that owns roles and things through those roles. And so essentially in my system, they're exactly equivalent, both of those patterns, and the sub leaves are downward edges, and there's these two types. And essentially when you look at group 2, that's really where I've got a nested group. So in this, I've got a thing that owns a sub attribute, and that's linked by some upward edge to a relationship that has a role, and that's been previously grouped. So when I want to get into groups of groups, there's two essentially equivalent situations, and it's really about the direction of the edge that joins the things. But the concept is I've got a main leaf with sub leaves, and that also owns a sub pattern. So that would be group type 2. And again, this is an extremely common type of group inside Kraken, TypeDB. Then next, what we often want to do is select groups of groups based on values. So that's where I've got a couple of different groups, and then I've got some value that I'm going to make disjoint so that I can select those, for example, a session ID or whatever. I want to be able to collect things. So my third type of group with what I call a group of groups is where I've got these essentially nested patterns, and what happens is these then have some common attribute through which they can be grouped. And then finally, I've got those things also grouped. So I've got a main leaf with sub leaves that owns groups of groups. So given that, what we have is essentially a group taxonomy with 4 different types of groups possible that we want to look at. If we wanted to kind of visually simplify Kraken, and essentially there's a leaves layer where I've got groups of leaves, and then I've got leaves connected to groups, and down here I call these ones groups of groups, and then leaves connected to groups. So when you see type 1 to type 4, they're the types of groups that I'm looking at. And essentially the proof is I built a little research prototype to prove that just changing the force graph algorithms, because some people said to me, oh, you just get daggery or YED or some kind of layout thing's going to solve the problem. Well, it's not, and I can prove that. That if we follow my 5 hypotheses, that it will actually achieve visual simplification. And if I actually follow all 5, it clearly does make a foundation for a new approach visually. And also the other question is that the taxonomy that I've put forward on groups actually accurately represents some kind of general TypeDB semantics. Might not cover all scenarios, but it certainly covers sufficient to make it useful. And I'll note up front that the software is a research prototype, not a production system. It's only got about 20 lines of CSS in it, so some greater level of expertise could certainly make it commercial. So let's just have a look at what a structure from Kraken might look like, and I'll just run that query again. So here we have a simple query where we've got a log with a log name L1. It's got an event with event names, and I'm looking for the traces and the first thing I wanted to say is, yes, I do have themes, and we're going to start off with the slate theme. Internet's a bit unstable apparently. And what we're going to do is we're going to run a query, and I'm going to run that. I'm just going to type that in. We're going to run that locally off on my local database. And what you can see straight away is that we've come back, and this is actually using the D3 force algorithm, and we've got something very similar to what the Graken picture is. The difference is I've done some summarization. So you can see here, I've got like these little dots happening here. I've solved the problem with the that you guys have here. But essentially it looks very similar. There's no real differences in the way that it lays out. The information's not clearer. I can see the clustering around the event name. I can change algorithms, and this web caller algorithm that I'm using will slowly separate things out. Now, this will give some visual clarity to the structure, but what we're still going to notice is all of these events, which essentially come from different user sessions, are all clustered around the attribute. So there is no way of understanding what any individual session does here. And so it's all a bit of a wash. Now, I'm actually going to charge out of this, and I'm going to change the theme. And the reason is because as we get more visually complicated, well, what you can see here is I've got a slightly different theme, and the colors work out better once I get a few things going on. So what I'm going to do is just start adding a few groups. And this is what I call a shallow system. In other words, I look through what we could call the apparent schema, which is the schema that comes back in the query. And so looking through that allows me to select any of the downward looking things and start forming groups around them. So the first thing I'm going to do is form a group of leaves where I've got a main leaf and some sub leaves. And I'm going to call that an event record, because that holds my event data. And as you can tell, my CSS has not always been successful with my theming. So it's a little bit dark there, sorry about that. But I'm sure that could get fixed pretty easily. Now, what I'm going to try and do is just define that group straight away. And what you can see is that it goes to the server and then gets saved inside here. And I can then define another group around using that group. So I'm going to put the trace, which holds the event data. And now we've got the trace record. Well, let's make that one yellow. And what we can see straight away is here's our clustered data. There's the actual event entity. There's my event data, which I've nominally got just a letter in there. That's what you do in process mining. Here's my array structure, where this is the array index, and this is my session ID. So that's my little group there. Oh, I did experiment with constraints, things like being able to set, indent and level, because this whole idea of this grouping was to form hypercards. And but I've actually removed most of the constraints at the moment, because really I just wanted to focus on getting the grouping right, and we'll do constraints looking forward. So let's just define that group, and you can see now I've got a group, I've got a nested group, and we're finally going to group of groups, and then we're going to go and look at that. So what you're seeing here is I've got a trace ID grouped by distinct value, which is the index. And when you look into this, you can see that I've got index 0, index 0. They've all got the same index 0. Clearly, that's not a useful thing. I actually want to group by the trace ID, because that's my session ID. And I can see my numbers change here. And now I'm all grouped by trace ID 0, and they've all got trace ID 0. So that's my user session. I'm going to mark that, and we're going to color that orange. And then we're going to save that. Now that I've defined those groups, what I want to go and do is go and look at the visualization of them. I could have gone kind of part way through, but I wanted to show people through the derivation. So if we use it web caller, the first thing I want to look at is this idea of adding shadows. So the shadows what they do, and you can see there these orange things here. What we can see in here, and we're going to zoom in, is that around this event name A, to all the events that it was connected to, I've inserted a copy, a shadow attribute. It's shadow because that's why it's lighter. It essentially contains exactly the same value, but now it's connected to the event. Every event has a local copy of this data. And I can actually disconnect those events to see if that actually clarified the situation. If we do that, what you can see is that, yeah, I've got some clarity going on here. You know, you can see it's starting to separate. I've got an event. I've got a trace ID 0 and that's second in the list. And it's got an event and a piece of event data. And I've got another trace ID 2. So I can see it's separating the individual pieces. But what you notice is horizontally, as I move across, it's all mixed up. So it's certainly not a sufficient representation. Visually, it's significantly simpler than this, but it's not a fantastic visualization. It's not quite there yet. So the next stage we're going to do is look just at the groups. So if we apply groups here, what we can see, and again, it all gets fairly complicated. What we can see is the groups. We can see them connected to the attributes here. For example, I'll pull that attribute out. Now, what I'm going to do is just disconnect the attributes because I'm going to kind of visually simplify things. We're going to remove the dark red things. And then that leaves us with a much simpler picture. Again, now, when I was talking before about the self-description, what you can see is, wow, I really need some way of understanding what's going on. And you can see that when I move over that trace record, I have got a summary, an auto summary of what's inside it. Now, the interesting thing about when you get into modeling or how you summarize things, what happens is the more containers that you move through, the bigger the elements of data that you're trying to summarize. And so eventually we start off with a piece of data has a very simple description. A group that just has 2 pieces in it has that's analogous to the way that I can add attributes in Kraken or the Workbase currently. If I move up to a more complex group, you can see that the full summary is written there. When I go to a final nested group, I can see that that's a session. It's got 4 trace records, and the condition through which it was grouped or disjointed was where the trace ID equals 3. And here we can see the trace ID equals 5, and the trace ID there 2, and etc. So I can kind of mouse over these things, and yep, there's some simplification here. It'd still be, I could kind of mouse over this and check back with my original matrix. Just go back to that original matrix and go, wow, this is the thing that I'm really looking for. Now, can I see that structure? Well, I'd give it maybe like a 5 out of 10. I can kind of like mouse over and see everything, but it's still pretty complicated. So the next stage that we want to look at is really about collapsing some of these groups to form composite objects or rich objects. And I can collapse those groups at different levels. If I try and collapse the event data, what we can do, I'll just disconnect the attributes. You can see those gray boxes have collapsed now to an orange circle, a gray circle. It's got all the data inside there, but now it's again visually simpler. If we collapse down to the next level, and again we disconnect the attributes, we can now see that we've got a very, very simple picture indeed, and that we can see that, for example, this has got trace ID 0, that I could drag and drop these things and arrange them so I could understand exactly what was going on. I'm not going to go through that level of detail where I drag and drop these things, but what you can see is I've got 5 traces. One of them's got 3 units. what you can see is 5 traces, and this is the one with the 3 units. So yeah, by dragging and dropping things, I could visually simplify it from here, but there's really no point. The point is, I think I've sufficiently shown the case that visual simplification through collapsible disjointed groups into composite objects is a way that we can really get at the data value of what's in Kraken. So a more kind of concrete, that's all very kind of academic, and I love my little theories, so I've played my little theory out. Let's kind of look at a bit more of a practical example, and this one's inspired by Daniel, because when I was showing through this, and I was going, what should I do for my demo? So I'm going to say there's 2 things about groups that I really like from here. Well, when I first started with the groups, I didn't think about collapsing them. That thought only really came through about 3 weeks ago. Once I collapse the groups, then I realized there's 2 things I can do with them that look really interesting. One is I can lay them out on the properties that they're based on them. And number 2 is I can create table export. Now, table export's maybe not that thrilling to a lot of people. It's thrilling to me because that then allows me to use a whole load of standard charting tools. And I said to Daniel, well, should I do the table export capability or the or try and do some kind of layout thing? And Daniel goes, try and do a layout. So this one that I'm going to demonstrate here is really a shout out to Heikel and James's tube network system. And I'm actually going to go and have a look at one of the one of the images from the tube network. I don't know if you guys have looked through the examples, but the tube network's a super interesting one. Hang on, Kraken. Let me just not talk, but get it. Tube network images. There we go. So if you haven't looked at the tube network before, it's going to look something like this. We've got a whole load of tube stations in London, laid out, and there's a few lines which route between them, and then some data that's shown over the top of them. Now, I can't show everything of that, but I can certainly show a first step towards doing something similar to that, but from a force graph. So what I want to look at here is I'm going to take in the first 100 train stations in London, and I'm going to load that query. And I'm not sure why that hasn't worked out. So hold on a second. Let's change this. Let's have a look at what it will look like. And just check that we got the database going okay. Oh, we look like we have. Oh, I know. The problem was that I have to change the key space. Whoops. And so the query didn't work because I had the wrong key space. I've done that before, so sorry about that. We'll load the query, and there's quite a bit of data here. So just to give you an indication of how much data we're looking at. So there's 100 entities. There's 4 attributes for each entity. So what we've got is we've got 100 loads of this. I'm going to drill into it so people can see what's involved. We've got a station. It's got a longitude and a latitude. It's got a NAPTAN ID, which is how I link it to the British Rail networking stuff, and it's got a title. And when you look at that, I just got a lot of those. I got 100 of them. There's like 900 edges. I got quite a lot going on there. If we have a look at what at what Grok and Workbase will make out of it, we can see that it'll pull the query really well. But then when I go and look at the query, it's again going to be pretty messy looking. And the question is, well, one of the key problems here is, well, wait for that to come up, but I'm going to look in at one of these things, is while my data is in pieces, that is separated from that. So in a mapping thing, I need those two linked together. I need a composite object that has a longitude and a latitude. I kind of can't have a longitude and then kind of map that without any real instructions. So that's not going to really, as it is, it's not going to work that well. Now we haven't got that back from Workspace. So what I'm going to do is I'm going to show you how composite groups can solve this problem. And so we're going to just like group the station up. First by the NAPTAN ID, then the name, and I'm going to add the longitude and latitude. And I will say, although I did this for Heikel and James to show them that I could produce an interface that, so you didn't need the T-Kinter stuff. I didn't want to do too much hand waving, but I do have a little bit of hand waving that's going on under the surface. So ideally in an interface, I would be able to have a control here that would click these and it would say register these two fields as a location and make this one a longitude and make this one a latitude. At the moment, I got a bit of code in there that says, oh, you know, if it contains the string LON, it's a longitude, and if it contains the string LAT, it's a latitude. So that's a bit of hand waving. Yeah, ideally, I'd have a kind of a way that I could select times or locations or other properties that I wanted to lay things out. But a little bit of hand waving away for the sake of the example. We're going to call this a station. Oops, station. I'll make it blue. And I'll move the little zoom box out the way. And what we're going to do is, you can see also I don't quite have the constraints working properly. You know, we've got a center where this is off-dented, but if I do the left edges, it doesn't quite pull together. So I didn't end up going forward with constraints for the demo. Sorry about that for anyone who's massively disappointed. I haven't done any constraints. This is really just a grouping and showing you the power. He's going to make a mess out of it, kind of like similar to what this is made out of it, which is way. So yeah, that you know, if your job is to look through that, good luck with that, because that's just going to be tricky. There's a lot going on there, and it's real hard to understand what's going on. As you can see, I can't make it much better, but what I can do is I can group it. Now, the web cola algorithm centralizes it all, so it kind of makes it a bit annoying, but you can see that if I show the groups, it's going to take a little while because there's a hell of a lot of things going on. What you can see is that the groups are still collected to all the attributes. So I'm going to disconnect the attributes. It's going to visually simplify it. And what you can see is that, well, let me get the right scale. Each station is now grouped. All right. Now, yeah, that's great. I've got the composite object, but it's not massively simpler. Let's collapse those groups into stations. Takes a little bit of processing. This may take a minute or two because there's a hell of a lot of objects going on. And what we find here, I can also disconnect the attributes. Okay. Oh, my main demo doesn't seem to be working for some reason. Then I had a little map button, and essentially what it does is just draw them out between minimum longitude and minimum and maximum longitude. But I seem to have a little bit of a error going on. Must be because I can't see the map button. So we could just run that again. See if it comes up. Maybe it was the way. Let's just try and collapse that again. If not, you're going to have to just take my word for it that I can collapse the groups into stations and then apply that longitude and latitude. But certainly that map is not turned up. So sorry about that. I can't finalize the rest of the journey, but what you can see, each of these stations has the detail. You can see this is a High Street Kensington Underground station. It's got the NAPTAN ID, it's got the longitude and the latitude. So you can see that these are actually mappable objects. And you can take my word for it that although the last piece of the demo broke, which is laying them out on a longitude and latitude between the minimum and the maximums, broke, you can see that the evidence is here that visual clarity can be gained by using disjoint groups. So I'm just going to go straight into my summary because I think everyone's probably bored by now. So I just kind of wanted to say that, so basically I think we've proven that the disjoint groups can map the TypeDB semantics. The shadow attribute adds clarity, but it's not sufficient by itself. Disconnection of attributes is important. Being able to describe the groups turns out to be a key thing, but it's really then about collapsing the groups that then enables things like longitude and latitude to be done. And, you know, I apologize about the demo. It's always the way it's demo. I must have tried it like 30 times before this thing anyway. Who knows why. But I think I've demonstrated that there's a foundation here through which we could visually clarify TypeDB and data in quite a powerful step. And although it's only a kind of like foundation, there's a whole load of other things that you could do. Ideally, in the future, I'd like to do Euler groups. I've done disjoint groups, but joint groups would be super useful because there's two set patterns in TypeDB. One is the disjoint type set, and the other one is the joint set. And what you can see here is like a disjoint group here, which is the square box, and overlaid with that is these joint groups. Now, joint groups are where I've got some overlap with some other group, and this is a very common thing in Graken. So I feel that when we have the disjoint groups and the joint groups together, you can actually get some huge clarity. But essentially, my future is really about I've pretty much done the semantic disjoint groups. The other thing is start doing local constraints to set up fixed dimensions, doing 2D page layouts like you've seen, and get the table export going. And then in the future, we'd be looking to do isometric type layouts, intersection groups, and that would create quite a powerful way of visualizing Graken. Anyway, that's pretty much, oh yeah, I also wanted to say thanks to Dr. Nick Fagay is a mate of mine. He works for Airbus. He's a guru in Archimate and modeling. He suggested the web collar. Professor Tim Dwyer wrote with web collar. Thanks, Professor Dwyer. And Daniel Crow actually suggested that I build this prototype for Cosmos. I'm sorry if I've disappointed anybody with my not excellent code quality. But I think I showed some interesting ideas, so I hope people were quite interested. Anyway, I think that's about me done. I'm assuming there's no questions and everyone's gone to sleep by now. So thanks for attending, and think about Type Refinery. Oh yeah, you guys can email me on Modeler on Discord, or you can hook up with Daniel if you're interested in what the future of my tool is. Thanks very much for your time. Goodbye from Australia.